Imagine a time when the universe was just getting started, galaxies forming, stars being born, but lurking in the shadows were supermassive black holes. How did these cosmic giants grow so massive, so quickly?
Exactly. We're talking about black holes with masses millions, even billions, of times the mass of our sun, just chilling in the early universe when the cosmos was barely a billion years old. It's mind-blowing. In this video, we'll take a deep dive into the history of supermassive black holes, explore the latest discoveries and studies,
And see how they've completely changed the way we think about the early universe and everything in it. This is Try New Space.
If we look into the history of these supermassive black holes, the first one was discovered in 1963, a quasar known as 3C273, which is 2.4 billion light-years away and has a mass of 800 million solar masses. But the first black hole to cross 1 billion solar masses was discovered in 1988, known as quasar TON 618, which has a whopping 66 billion solar masses and is 10.4 billion light-years away. But the first supermassive black hole from the early universe was discovered in 2003, which has 3 billion solar masses, located 13 billion light-years away. It doesn't end there.
From 2003, we have more than several hundred early supermassive black holes discovered till 2024. Thanks to the recent deployment of JWST, the numbers kept increasing year by year. So let's start with a discovery made with the Hubble Space Telescope, a 14-year study that peered into the farthest reaches of space, the Hubble Ultra Deep Field. We're talking about seeing galaxies from when the universe was less than 500 million years old. The Hubble Ultra Deep Field, or HUDF, is one of the most profound and detailed astronomical observations ever made, capturing a small patch of sky in the constellation Fornax. The HUDF reveals around 10,000 galaxies, some of which are among the oldest and most distant galaxies ever observed, dating back to just a few hundred million years after the Big Bang. Many of the galaxies in the image are incredibly faint, small, and red, which indicates that their light has traveled across cosmic distances for billions of years before reaching Earth.
So, a team from the Stockholm University were looking for faint objects that varied in brightness over time. The reason to look for faint objects that varied in brightness is to find a particular type of black hole called active galactic nuclei. An active galactic nucleus, or AGN, is the super bright core found at the center of some galaxies, powered by a supermassive black hole. When material falls toward the black hole, it gets superheated and releases a massive amount of energy, making the core glow intensely. AGNs can shine so brightly that they outshine all the stars in the galaxy combined. And you know what they found? Out of 71 variable sources, they discovered three supermassive black holes, or AGNs, that existed over 12.7 billion years ago. That's back when the universe was just a baby.
If you think about it, we found 3 in just one tiny patch of sky. That means there must have been so many enormous black holes during the cosmic dark ages. It's like the universe was teeming with these monsters, much earlier than we thought. But how did these black holes grow so massive so quickly? Well, there are a couple of theories. One says they might have formed right after the Big Bang from the collapse of immense gas clouds, thousands of times more massive than our sun.
Yeah, and these massive gas clouds would have collapsed straight into black holes without exploding as supernovae like the stars we know today. Some scientists even think the first generation of stars formed in huge compacted space with matter and dark matter in the cosmos might have been giants, thousands of times bigger than our sun, collapsing into intermediate black holes. And those black holes? Well, they just kept feeding. These stars are believed to have formed around 150 to 200 million years after the Big Bang, and then rapidly began accumulating matter, leading to their swift growth, growing into these cosmic giants.
But wait, it gets better. Yes, fast forward to today, and we've got the James Webb Space Telescope, the new kid on the block, peeking even further back in time. JWST discovered something wild, a supermassive black hole that's 40 million times the mass of our sun, just 700 million years after the Big Bang. And the kicker? This black hole in the center of the galaxy seems to have more mass than average compared to the rest of the galaxy's mass, which is rare. This thing was eating gas and dust like there's no tomorrow, and the light from it was super red-shifted because of the universe's expansion. The light had traveled 12.9 billion years to reach us, and thanks to gravitational lensing of a nearby galaxy cluster, which acted like a natural magnifying glass, magnified this galaxy and its black hole, which JWST caught a glimpse of. Without gravitational lensing, we wouldn't have seen those 3 red dots in detail, which all turned out to be the same object. A massive black hole, of course. Gravitational lensing distorts the fabric of space and time, which may result in multiplying the object.
But seriously, how did this black hole grow so massive so early? That's the big question. And we still don't know for sure, but one thing's clear. These early black holes didn't follow the same rules as the black holes we see today. The ratio of black hole mass to the mass of their host galaxy was way higher back then. The universe was much denser and compact in size. Scientists believe that supermassive black holes grew to their enormous sizes through the gradual merging of smaller black holes over time. According to our current Big Bang model, this process should take billions of years. However, the mystery remains as to how some black holes managed to grow so rapidly in the early universe, which still puzzles researchers.
It makes you wonder, did the black hole grow first, or did the galaxy come first? It's the cosmic chicken and egg problem, but on an epic scale. Yeah, and the evidence is starting to lean towards the black hole coming first. This whole tentative conclusion came from a group of MIT scientists who used the JWST to look at light from 6 ancient quasars. These quasars observed are consuming material from their accretion disks, which are turbulently swirling, causing them to emit a bright glow. Quasars are the most luminous objects in the universe, often outshining all the stars in their vicinity combined. They found that these black holes could have formed from something called heavy seeds right after the Big Bang.
Exactly. The idea is that these heavy black hole seeds were way more massive than the black holes we see today, and they started consuming matter and growing like crazy before their galaxies even had time to catch up. The evidence they found was by converting the light data observed from these quasars into a data that estimates the mass of the galaxy except the black hole and the black hole itself. They found these quasars in the early universe had masses about 10% of the stars surrounding them. This is quite different from what we see today, where central supermassive black holes typically have masses that are only around 0.1% of the stars in their galaxies. This significant difference suggests that the early universe operated under different conditions than what we observe now. It's crazy to think that less than 1 billion years after the Big Bang, these black holes were already dominating the cosmic landscape, growing faster than their galaxies.
And now the JWST has only just scratched the surface. Who knows what else we'll discover about these cosmic giants and the role they played in shaping the universe as we know it today. The mysteries of the early universe are only just beginning to unfold, and with every new discovery, we're getting closer to understanding how supermassive black holes grew so massive, so fast, in such a short period of cosmic time.
Well, I have made a video about the recent discovery of the largest black hole jet in the early universe.
Or this video, where it's very plausible that our universe might be inside a black hole. Let me know what you think in the comments section.
This is Try New Space. Stay curious, and I'll see you in the next video.